Chapter 7, Section 7, which is the last section for Mat 1033, dealing with complex numbers, imaginary numbers, complex numbers. All right, first thing you've got to understand is that the square root of -1 is I. I squared is -1. I to the third power is -I. I to the fourth power is a +1. That's all we really need to know, because then what happens is I to the fifth becomes I. I to the sixth, -1. I to the seventh, -I. I to the eighth, 1. And it just repeats itself. I to the ninth, I to the 10th, I to the 11th, I to the 12th, so on and so forth. A good way to look at this is that if you divide your exponent by 4, if you get a remainder of 0, then you know it's 1. If I get a remainder of 3, then that's -I. If I get a remainder of 2, then so it's -1. And if I get a remainder of 1, I know it's I. All right. So what happens here is, here's two problems where we have negatives inside the square root. Now, I know we were taught earlier that you can't have a negative in the square root, which is true. The number becomes imaginary. So what happens here is that we have a square root of -36. The first thing you should do is bring the I out, which brings the negative. Whenever you bring the I, it's bringing the negative out. Now I can take the square root of 36 and I get plus or minus 6i. If I come over here to square root of -5 and I take the I out, I get I squared of 5. Can't do anything more with this because 5 can't be reduced or simplified in a square root sign. I always want to put the I in the front. Don't put the I in the back, because it's very easy to draw this radicand sign and make it look like the I is inside when it's not. We also have multiplication of imaginary numbers. For instance, if I go square root of -36 times square root of -1, then what I really want to do is I want to go bring the I out, and now I go I times I, which gives me I squared. 36 times 1 gives me square root of 36. I squared is -1. Square root of 36 is plus or minus 6. So this actually gives me plus or minus 6. Because even if I didn't have that -1 there, it'd be plus or minus 6. But when I multiply by -1, I still get the same thing. If I come over here and I add or subtract complex numbers. Now remember, a complex number is where we have an imaginary and a real number added or subtracted together. When we have this format, the real number always goes in the front, the imaginary in the back. That's the reason they have A plus BI. The A represents the real number, the BI represents the imaginary. Together, A plus BI is complex number. So when I have 2 plus 3i plus -3 plus 2i, it's just like combining like terms. I'm going to take and add the 2 to the -3. So I'm taking the 2, adding it to the -3, I get -1. I'm taking 3i plus 2i, getting 5. So all I can do is add or subtract real to real, add or subtract imaginary to imaginary. If I come down here and multiply complex numbers, I want to do the same thing. This is really a binomial times a binomial, so I treat it the same way. I multiply the 2 times the 4 and I get 8. I multiply the 2 times the I get 2i. I multiply the -5i times the 4, I get -20i. I multiply the -5 times the times the I get -5i squared. So then what happens is I squared becomes a -1 times a -5 becomes a +5. Now I can combine like terms. 8 and 5 are 13. 2i minus 20i is minus 18i. I'm done. Don't forget that the I squared is a negative 1. It's very important. I to the fourth power, positive 1. We come over here, and if you remember with radicals, we multiplied by what was called a conjugate. Well, when we deal with complex numbers, we're going to multiply by the complex conjugate. So remember I told you in radicals that the conjugate was nothing more than the second part to a difference of squares. So it deals with the same first term, same last term, opposite signs. So see, this is 1 minus I. So we're going to multiply the bottom by 1 plus I, but in fractions we got to whatever we multiply the bottom by, we're going to multiply the top by the same thing. If I multiply these two binomials, I get 2 plus 2i plus I squared. If I multiply this, 1 times 1 is 1, minus times plus is minus, I times I is I squared. This then becomes I squared here becomes a negative 1. 2i and I is 3i plus 2. This becomes, I squared becomes a negative 1, so this is double negative. So now I get 2 minus 1 is 1 plus 3i over 2. And if I want it in a plus bi form, I move the 2 underneath the 1 and get 1 half. I move the 2 underneath the 3i, get 3 halves I. Now I'm in a plus bi form.